Welcome back. We're picking up where we left off. Last time, if you remember, we graphed quadratics in factored form. Just a little refresher, what we did was follow these steps. We first set each factor equal to 0, solve for x. That gave us our x-intercepts, which is what factored form is really good at. So that was the first thing we did. And then we went about finding the vertex and a few other points. So because there are three different forms, they specialize in three different things. So the way you graph them, or the process, I should say, is a little bit different. For example, vertex form. Vertex specializes in what? Finding the vertex, of course. So that's the first thing we're going to graph. So what is the vertex? Do you remember how to find it? I'm also reminding you here that it's h comma v. Well, we have dishonest h right there. Dishonest because it's the opposite of what you see. So it's actually 1, not -1. And v is there, -4. There's not only our vertex, but our axis of symmetry as well. That is a nice way to start, isn't it? Okay, great. But I'd like to find some more points. You could just plug in different x values and find the rest of the points and call it a day. But me personally, I would really prefer to find the y-intercept. It's kind of it's a way to graph another point with also finding the y-intercept. So that's preferred because sometimes you're asked to find that specifically. So y-intercept happens when x is equal to 0. And now we need to follow our rules of PEMDAS. Can anything be done inside the parentheses? Yes. Are there any exponents? Yes. And 2 times 1 is obviously 2, so 2 minus 4 is -2. So when x was 0, y is -2. So there it is. We found not just another point, but we also found the y-intercept. And using our axis of symmetry, we can find another point, right? 1 unit away gives us another point just on the other side. And it's good practice to always find one more point. You could pick -1 or 3 or something else. Me personally, I'm going to pick -1 and see what happens. Okay, so I'm following PEMDAS again. What's going to happen? I have 8 minus 4 is 4. So when x is -1, y is 4. -1, 4. Boom, way up there. Okay, this is 2 away from my axis of symmetry, so let's go 2 to the right, find another point. Isn't that nice? That axis of symmetry is a nice guy. Really helps us out, huh? There we go. There's our parabola, and please note, a parabola has a curve at the bottom. It's not a sharp point like that. That is a different type of function that we're not looking at today. Vertex form, there it is. And finally, standard form, probably the form you're the most familiar with. Can you fill in these blanks? Can you graph this, just like we've done in the past? Remember, a, b, and c do not involve variables. These are numbers, coefficient of x squared, coefficient of x, and the constant. Now, this is a handy little formula. You absolutely need this. If you are given standard form and you need to find the vertex for one reason or another, this is the formula you need, so make sure you have it in your notes, along with what it's used for. Okay, so the x value of the vertex, so I'm going to say x of v, is -b over 2 a. Well, that's just negative 2 over 2, so negative 1. Okay, just like we always do, it's time to plug that x value back into our function to find the y value of the vertex. Let's see, when x is negative 1. Negative 1 squared is positive, minus 2 minus 4. Well, that's basically 1 minus 6, which is negative 5. So our vertex is at negative 1, negative 5. Interesting. Interesting that, again, with vertex form and standard form, the first thing we graphed was the vertex. But did it have to be? No. We could have started by graphing what standard form specializes in, which is finding the y-intercept, C. We identified C right there. We'll identify it again. It is negative 4, y-intercept. Boom. Right there. And use your axis of symmetry, right? Find that other point just on the other side. Okay, let's make some room so I can find one more point. Here we go. Actually, I'll bring that back in case I'll just try to make room. See if I can not remove anything. There's your vertex. All right. Let's pick a point. I'm going to pick 1. The smaller number seems to be the easier. So let's section this off. We're running out of space here. That's 1 squared plus 2 times 1 minus 4. It's going to be 1 plus 2 minus 4. That's 3 minus 4. That's negative 1. When x is 1, y is negative 1. 1, negative 1. Bada boom, bada bang. 2 away. Same thing on the other side. And eureka! We have it graphed. You can see how these can take a while, but you get pretty fast at it over time. I did not graph this that fast the first time I ever did it. So practice, practice, practice. And we already finished graphing that. So we're on track now to do exactly what I just said, practice specifically for your quiz. And this one's going to help you with number 6. It's going to ask you, it's going to ask you specifically to rewrite the equation in vertex form. That is an odd looking function, wouldn't you say? Looks like all the x's and y's switch places. Because they did. This is something you've probably never seen, and this actually means the parabola is sideways, like you see here. But don't worry, you're not going to need to graph sideways parabolas, okay? What you will need to do is rewrite it in vertex form. So we're just, for the sake of this problem, thinking in terms of, okay, the x's are the y's and the y's are the x's. Follow the same steps to complete the square. If you don't remember all the steps, you can, of course, watch this recording over and over, but I also have the 3.07 lesson from semester 1 in the recordings document if you'd like more practice with that, okay? Do you remember how to complete the square? If you do, go ahead and test yourself right now. If you don't, we're going to do it together. There's the steps on the side. Let's go. Now, since we're thinking of this in reverse, where the x's are y's and y's are x's, we need to move the x to the other side. Step 1. Get that to the other side. You know how you always see y equals on one side? Exactly. Now it's x equals. And here's our quadratic with our y's. We now want to use the two y terms to complete the square using this little helpful tool. Remember, this gives you your, actually, yeah, I did miss this part. We didn't need to only move the x, we also need to move the constant. I'm going to rewind and do that in the same step. Minus 19, minus 19. Okay? Why? These are just the steps when completing the square. Now, I left space there, and I did that on purpose because there is a missing magical number. I like to call it magical because it helps us complete the square, even though it's not magic. We're going to use formulas. That b over 2 squared I just talked about. Okay? So what is b? B is the coefficient of y. Just like b is the coefficient of x when you're thinking of this and the normal way you usually see it. So b is -8. And what do we get? Simplify what's inside the parentheses. -4 squared. We get 16. And I'm going to use a different color because this is an important part of what we're doing. So if you get 16, you're adding 16 to both sides of the equation. And now look what you've done. You've completed the square on the left. So if you've completed the square, you rewrite this perfect square trinomial. That's where the name comes from. You've created a perfect square trinomial and you completed it by adding that 16. This is how you rewrite it. Number 3, okay? You have your parentheses. And you have your first term plus or minus the third term, but not just the first and third, the square root. So let's rewind one step and we'll take the square root of the first term right here. So square root of y squared. Square root of the third term, 16, that's 4. Now we're going to rewrite it like this. So we have y. Is it plus or minus? Well, we got, what do we have? I'll determine that in a moment for their squared. So I rewrote this, but I didn't put plus or minus because what that requires is going back to the original trinomial and asking yourself, is there a negative in there? If there is, then it's minus. If these are both positive, then it'd be plus. That's how you determine that. And what do we have on the right side? Well, we had -19 plus 16, so -3. That's looking real close to vertex form, isn't it? But what do we want moved? We'd like to have the x by itself, right? And remember, when you have your binomial squared, that constant being added or subtracted should be on the same side. So what I'm going to do, I'm going to add 3 to both sides, and I'm going to write it at the end like that, because that's what we're used to seeing vertex form look like. Now it's in vertex form, and we've successfully completed this. And you can move that x to the other side if that makes you more comfortable, if you want to see it like that. And that should definitely help you anytime you're converting from standard form to vertex form. Could look like this, could look more normal, where you see your x's as the main variable. Now we're just going to spend a little more time practicing. So for the rest of these, I'm suggesting you do exactly that. You pause it, take some time, try it, and check it. Okay, A, determine the direction the parabola opens. Well, I see a minus out front. Negative A means down. It opens down. So it's going to look kind of like this, right? Determine the vertex. Okay, lucky for us, it's in vertex form. So H, dishonest H, V, elevator V, -2, 3. Boom, vertex. If you want to label it, write out vertex, whatever works for you. Okay. But then they ask us a question we haven't been asked today. Is it a maximum or minimum? What that's asking you is, where is the vertex? Is it at the top or is it at the bottom? So in this case, we would say it has a maximum. Okay? Because it's going to have a limit at the maximum, at the top. Okay, determine the axis of symmetry. Well, lucky for us, this is in vertex form, so all we have to do is draw a line through the vertex. I'm going to change that point so it's easier to see. Okay, so we've done A, we've done B, we've done C. Determine the x-intercepts. How can we do that? X-intercepts is next on the menu anytime y is 0, right? So we set y, aka f of x, equal to 0. And let's see what happens. Plus 3, there we go. Okay, well, we want to solve for x. That's the goal, right? So undo what's easiest first. -3, and then we have all of this. What do we do with that? What's the easiest thing to undo? I'd say divide everything by -3. And not only does that get rid of them on the right, but this turns into a 1 on the left. So we have x plus 2 squared. All of a sudden, a complex equation is looking quite simple, quite nice. Well, we need to undo squaring. We know that's square root. Don't forget your plus or minus. Okay, so what do we have now? We have positive or -1 because square root of 1 is just 1, right? Equals x plus 2, right? The radical and the square cancel each other out. That's the whole reason we did it. Well, last but not least, subtract 2 on both sides. So we have 2 x-intercepts, right? So what are they? We have -2 plus 1, and we have -2 minus 1. -2 plus 1, -1, -2 minus 1, -3. These are, both of them are x-intercepts. Okay, so -1, -3, and this is looking like a pretty narrow parabola, isn't it? Pretty narrow indeed, because this is going to shoot down kind of like that, right? What did they ask us last? To find y-intercept and graph it. Well, we've been graphing it, right? So really, only thing left to do is find the y-intercept. Found that, we're doing that. How do you find y-intercepts? That's once again when x is equal to 0, right? 0. So you might be in the beginning of this lesson thinking, oh, there's all these different forms. It's going to get tricky. There's a lot of things in common, right? You're doing a lot of the same stuff. So PEMDAS, 2, okay, 2 squared, 4, -12 plus 3, we get -9. So y-intercept at -9, it is off the charts just a bit, and that's 2 away from the axis of symmetry. We're going to have 2 points right about there. Let's draw this steep upside down parabola. There it is. That's the same thing. So let's move on to this one. This is the last problem we're going to do in this lesson, by the way. And then you'll be prepared for the quiz. Consider this quadratic function. What form is that in? Well, it says it factored, and you should notice, oh, I see two factors. Okay, I'm not so much going to talk through this one. I'm more so going to do and then explain afterwards. I will talk about x-intercepts for a second. So remember we said they're always going to be x1, comma 0, right? And x2, comma 0. Well, what is x1? It's the first x value you get, right? But remember, you need to set these equal to 0. So if you set x minus 1 equals to 0, you get positive 1. If you set this equal to 0, you get negative 3. Vertex, vertex, okay, x of v. How do we find the vertex for this? Do you remember? Well, there's that formula, right? If you know your x-intercepts, it's x1 plus x2 over 2. It's the average distance in between, right? Where's the middle there? So we have negative 3 plus positive 1. So I don't need parentheses there. Over 2. Negative 3 plus 1 is negative 2. So this is negative 1. So that also tells me axis of symmetry. So D is done. Okay. Two times 2, negative 4. So vertex is, x value is negative 1, y is negative 4, negative 1, negative 4. There we go. And is our y-intercept going to help us on this one? Maybe. Maybe it might help you find some other points, but it's not really going to help determine how high up the graph goes. So I would pick maybe 2, something like that. So you can find a point somewhere up here and over there. We've done that several times, so I'm not going to do that again. You just plug in 2 into your function, and you'll get your graphed line. And that, my friends, is the end of 2.06. You've practiced, you've learned, but you can always practice and learn more to sharpen your skills.